right, everyone, get ready for a session packed with excitement and fresh ideas. Vani Mishra, Quest's own Director of Product Management for Erwin, and Bernie Pruce, a leading Snowflake industry expert and CEO of Cloud Data Consulting, are here to take us on a journey into what the future of data modeling looks like. Think of it as a sneak peek into the data world of 2025. They'll be talking about how data is evolving, AI is changing the game, and new regulations are shaking things up, all centered around how Snowflake is leading the charge. And with that, let's jump right in.
Hello and good morning, everyone. Welcome to our very interesting, factful webinar on behalf of Erwin Quest team, Data Modeling 2025, Trends and Deep Dive into Snowflake. So I have a very special guest today. So let's get into our agenda for today. So I would like to introduce you to my guest, but before I pass the ball to him, a little bit about myself. You may know me. My name is Vani Mishra. I'm Director of Product Management, working with the product Erwin for 20 plus years. I don't want to call it myself expert, but I'm absolutely passionate about metadata and data modeling and data governance. Bernie, would you like to introduce yourself?
I'd love to. Thank you. My name is Bernie Pruce, as you'll see on the screen. I have been data modeling for longer than I care to admit. It was when I learned to data model about 1992, 93. And for me, that's when the lights came on around databases. I loved to do CAD/CAM in college, which was computer-aided design, computer-aided manufacturing in electronics. And for me, the having a data model is like having the best way to see your data and the relationships. I've been building data warehouses since 1999. I'll date myself a little bit. The first big database I worked on was Oracle version 6, then 7 and on up. I've built data warehouses on Oracle, SQL Server, Teradata, Google BigQuery, and Postgres. And most recently, Snowflake. I've built 19 Snowflake data warehouses that have gone to production in the last 6 years. And I'm very passionate about data modeling and data analytics platforms. And I cannot work on a database without a data model.
Great. Thank you, Bernie, for joining today's session.
Yep.
So, as I said, today's session is pretty interesting. I'll let Bernie speak more. I promise that. But I definitely would like to speak and share my engagement with all of you and other customers globally across the world. What I'm seeing when I'm going and meeting my customers. And then I want Bernie to spend most of the time on Snowflake, what he has been seeing with his customers. And he has a very interesting case study. And I hope that he will do the demo and show us that case study. And at the end, I would like to update everybody about our recent release of version 15 and what's coming next. So with that, let me get started with a little bit about let me just set the platform here, where we are getting into. So the evolution of data modeling. So we all agree that traditionally, because if you started doing the data modeling in late 90s, early 90s, and so on, and 2000 until today, traditional data modeling, the purpose of traditional data modeling is build your ER diagrams. We saw it as more like a monolithic approach, waterfall methodology. We are all trying to build a normalized, a second normalized model, third normalized model. We are trying to build a static documentation, and all of our data models were centrally controlled by DBAs or somebody who has access to databases. So it's the goal was more driven for data storage focus, and it was all around normalizing the data model. So now we have seen over last 10 years we are moving away from that path slowly. Getting our focus is shifting to data uses. We are getting into the data consumption, business analytics report, BI reports, and today when we are into AI world and an agentic world, everything, the entire the modern data stack has completely reshuffled, and we see that distributed multi-format where you have data coming from different sources. You are trying to assign fill in the requirement from different kind of reports of whether data is coming from in a video format or in an imaginary format. It's coming from all the different directions. We also see that there is, of course, it is requiring the polyglot, it's requiring the NoSQL data models. It's also, everybody's, I hear talking about graph database, Neo4j's in every other discussion that I meet my customer. And the goal is, hey, I would like to keep the minimum effort and make the coding go faster. Can I have a SQL right from there? Can I make my pipeline, my CI/CD be more effective? My Git, my version control be more impactful, and get the speed is the key. And at the end of the day, I would like to have a governance around all my distributed multi-format database system. And now we are moving into data as a product mindset. So I have more details on that, but that's kind of a modern database modeling looks like. And Bernie, what do you think? You agree with that?
Absolutely. And I'm looking forward to, continuing our dialogue about this. This is fun. It's evolved over time. That's what I would say.
Yep.
It's
Yep.
very different.
And I also see, Bernie, that you might see with your customers as well that people are not only looking for a SQL base, but more like a Git controls environment, a CI/CD control, like you and I spoke many times, DBT or OS or any kind of tool. More automation, more governance, more active metadata platform. So data and metadata is the critical key for everything we do today. Building the business glossary, you have and Bernie, we have a tool called Data Intelligence, which is a great tool in the market to build your business glossary. And with new features where we have data intelligence is very tightly integrated with DM, you can bring your glossary, build your model, make your metadata, your entities and attribute affiliated with that business glossary. So your data model becomes golden source of truth for your elements, your data assets, your tables and columns, whereas your product like data intelligence becomes the golden source of truth for your business glossary and business terms, and you can build your lineage and whatnot from the tool. The third part that we all agree that we are all every day involved in data warehouse modeling, bread and butter. That's not going to go anywhere. I also notice a lot of customers are getting engaged in more refined data modeling practice like Data Vault. And I have been asked about open API modeling concept where, it is more geared for data scientists, DevOps engineers, data engineers who would like to build a framework where they can put all kind of application rather than rewriting it. The framework is ready to go and they can reuse the different segments of it. And traditional data modeling, I don't see it's going away anywhere, but I will definitely say that new trends are gonna make a big huge impact on our everyday traditional practice. In that, Bernie, I just want to inform you that every customer I meet, I come across something called data mesh and data as a product. I see this coming at very fast in almost every other discussions that people are moving from their monolithic data architecture. I am sure your customers are dealing with the same, where they see that monolithic architecture, our traditional architecture is cumbersome, it's expensive, you cannot apply innovation that fast. Whereas data mesh is completely opposite of centralized mindset. It's data mesh is all about decentralized approach to manage and share the data with an organization and treating data as a product owned by domain specific teams. So I see that data mesh aims to link data producers directly to data users. So that is a big thing here. Your producers are still the domain driven, and your consumers are who are gonna utilize those data as a product. So basically I see that traditional centralized warehouse model is more, we are moving away from that. We are getting into domain oriented. That's part of our discussion. I see that people would like to have self-service data structure, federated computational governance around it, and your everybody is in sync. It's a seamless. If you're talking about customer in one domain, that same customer, the definition or meaning of the same customer means the same thing to the other domain. Now, I see a big value here about data mesh principles, and especially I want to give a credit to pioneered by Jamak Degani. I definitely would like to bring her name here. She has done a great job and written a very valuable book, Data Mesh. If you had a chance, Bertie, take a look on that. But basically, what her idea is, in a business point of view, data mesh is basically pushing people, introducing to get more innovative and think as a data as a product, right? And basically let me give you an example. So let's say if you want to improve your decision making, you want to help detect your fraud alert for your business, or you want to inform your supply chain conditions, or another, if you're in healthcare, let's say you have a critical patient information is building on, you want to inform your patient, hey, you have changed your address, you have not visited your doctor. You want to come up with your new ideas about your product, about the data, and that product as data as a product thinking can really take you fast. So domain oriented ownership is, so these are the principles that everybody kind of knows. Domain oriented data ownership, data is owned and managed by the team who are the closest to the data source. For example, if you are coming from marketing, sales, or finance, so rather than dumping everything in central system, you as a domain owned or ownership is very important. People who really understand that data, where it's coming from. The second thing is data. It pushes you to think data as a product, because you own the data. You can maintain the quality, you can maintain the usability, and third and most important in domain driven is data is discoverable. So whenever you need to have information about customer ID or some sensitive information, you can go to the owners of the data and find that information. The other thing that people get benefit from data mesh principle is self-serve infrastructure, which basically idea is to provide a platform that allows domain teams to manage, access, and share the data independently. And overall, federated computational governance, federated governance, where it establishes a consistent set of rules and standard for data sharing and making sure that the meaning of customer is same across the board, even with the different domains, if you have any or you're sharing the data. So I agree with all the customers who are shifting their mindset. It's a huge paradigm shift of data mesh or data as a product from our monolithic system that we've been living for last 30-40 years. Because I clearly see that a lot of customers are getting advantage, or they see the advantage that this kind of product, data as a product, gives the more clarity to the data value. It makes you more innovative, it's agile, it's fast, it's a democratizing your data, and it gives you the flexibility. So modeling the domain is, and every story starts, anything starts with data modeling. So because you are moving from a monolithic to data as a product, modeling becomes more essential than before. That's how I see it, and I also see that my customers are going in that direction. So that is one piece that I see driving the market very fast, and almost every customer I come across, they are looking into that path. The other thing that is going to lead this world, our everyday life, is AI. And it's, of course, it's going to lead our data modeling practice as well. So how AI and agentic AI is going to lead the data modeling practice. We started with AI, we got into Gen AI, and Gen AI is going to lead and produce more better data products. And then agentic, where our customers don't want to do the clicks, manual clicks more, but more like a natural language where they can type in, I would like to reverse engineer my Teradata. I'm just going to pick my name and build a model and convert that model into JSON. And in our case, save that model into MART. That's kind of a agentic thought process that I am telling agent what exactly I want, and I'm more like looking for the result sets. So I definitely see that the data modeling is going in that direction. All the vendors should start thinking on that. At least we have started looking in that direction. And cloud native strategy is very important when you are looking in artificial intelligence world. So with that, I'm going to pass. I don't want to take too much time from Bernie, but I just want to conclude with this picture, because this summarizes everything that we see in the modern data technology stack. We see advanced BI tools, we see the warehouses there, meshes there, APIs, microservices, and data lakes is going to play a big role. Of course, metadata is going to be the key feeding factor on it. So that gives a good segue to get into our today's highlight, how data modeling is going to be helpful in Snowflake world, what's new in Snowflake. So with that, I'm going to pass it to Bernie.
This is a great slide to really talk about how things have changed so much. And as you were talking, I was thinking about one of the things you said is that every client is different, or every big company is different, or small company. And I was thinking back to my career experience, and there have been one of the things for the first huge part of my career that I noticed that was missing was sort of a software engineering approach. So you were talking about having things in source code control, Git, or in CI/CD. For the longest time, when I would show up at a client, sometimes very large clients, they did not use source code control for their data warehouse or their data analytics platforms. And so I'm really excited to see the data engineering stuff advance. And I also notice huge differences as I go across. So I was very fortunate enough to work with a lot of big names in addition to some smaller companies, but Reader's Digest, Citigroup, Stanley, which is now Stanley Black & Decker, Kaiser Permanente, Charles Schwab, Western Union. All of them were different, and some of them were more mature. One of the most mature was when I was at Charles Schwab. They really used the entire Erwin data stack and ecosystem, and they had a process that was super mature. And I think at any organization, I really think the process of continuous improvement is really important, because when you show up at a new organization, or if somebody joins a team, you got to start with where they are and just keep improving continuously. And what I'm really excited about in the last few years is just how much more software engineering practices we're able to deploy, implement, and use from the very beginning. So that's what I wanted to share on that slide. So now Snowflake is one of the big, huge modern upgrades in cloud compute and cloud data platforms. And I found Snowflake about 2019. And as I started to learn about it and I started to understand it, I realized that this was something very different than anything else that I've seen before or since. And the way to explain it is, I think, is that they started after the cloud was already popular, and there were a lot of things already moving in the cloud, and they built it from the ground up to be cloud native. And compare that to many, many, many other products. What they do is they had an on-premises solution, and then they'll run it in a virtual machine in the cloud, but it's the same architecture under the covers. Snowflake built everything to take advantage of the cloud. And so their compute is managed in a way that it can scale. It's totally separate from storage, which was new. There may be a couple of products that do that now, but nobody was doing that, I think, when they started doing it. And either one of them can scale independently to near infinity. And that is so powerful. They also have set it up so that the maintenance that we have to do as data warehouse practitioners and data practitioners is super low by comparison to other tools. So we can, and just a couple things I mentioned there is auto start, auto scale, zero cost caching, all of that stuff. All right, good. I'm glad you went to the next bullet points. So they also keep providing more and more features every year. It's really hard to keep up. They've added so many more features. I'm just going to keep it simple and say they have tons of ELT now available in Snowflake, and you don't have to pay for another vendor to do it. And we might talk a little bit more about dynamic tables later, but let's go to the next bullet. AI, well, machine learning has been around for quite a while. AI has been all the rage for the last couple of years, and things are moving so fast in that area. It's really very hard to keep up for even those of us who are doing it every day. A couple things that are very important about the way Snowflake has set things up. I'm always frustrated when I see a demo where a vendor will connect to Snowflake and pull the data out of Snowflake to run their algorithm outside of Snowflake. What Snowpark does is it's a set of compute clusters or compute that is right there with the data, and so you don't have to move it. There's no network traffic, to speak of, and it's all right there. You don't leave the region. The same kind of thing for the native Python running there. Now, the next thing is AI, large language models, machine learning. They have set it up so that we can do retrieval augmented generation very quickly, and we can train our own large language models. And jumping to data sharing and interoperability, another feature that saves us a fortune in time and energy and calendars drifting is being able to securely share our data with vendors, partners, other companies, or even to monetize it and sell it out into the world without that data having to leave Snowflake. People just connect and get it out of your Snowflake account, or you share it. And you can purchase data for our the case study I'm going to talk about in a minute. We were able to purchase weather data so that we could plot sales next to, was it a sunny day or a rainy day? And in the hardware industry, sun and rain and makes a really big difference in sales. So anyway, I think that's enough of that. So this slide, what I want to represent is the big context of Snowflake and where it sits in everything. And then inside of Snowflake, we have a lot of options about how to configure and use things. And this is just to show the basic flow that typically we have tons of sources on the left. And when you start with a few. And then as the program matures, you keep adding sources. We will load that data either with a Snowflake native tool, or we like Matillion, we like Fivetran. We will load that data, and then we have it in a raw database. Then we use a transformation tool like Coalesce or dbt, which transforms it into the star schema, which is really easy to use by all of our BI tools. Now, if people already know data warehousing and BI, that might be obvious, but just in case anybody is not in that frame yet. And then your BI tool, it might be Sigma, Omni, Tableau, Power BI, or Looker. And let's go to the next slide. So there's so many reasons why data modeling is important in a modern data program. And one of the first things is whenever you start on a new project or a new program, or you show up, and for us as consultants, we show up in a new customer relationship on a pretty regular basis. And the first thing we have to do is understand their business. So we've done a lot of retail lately, but no two retail environments are identical. They use different language for the same things. They have, it's the classic thing in modeling, right? Is we need to know the definitions. So we need to talk to the business. We need to understand. Then if we don't have modeling and we don't capture the data catalog and the definitions, over time, we'll have to answer that question over and over again. So really, I think that's what I want to say about on that slide, unless you have any questions as we go. All right. So here, I'm just going to talk about kind of the process we use, and then I'm going to demo some of this in a little bit. So when we show up, we want to understand the business. So we'll do top-down data modeling. We will talk about the nouns and the verbs and get the nomenclature that the business uses. Then we start to load the data into our raw area in Snowflake, and we can then data profile it and then reverse engineer it into Erwin so that we can see what the data looks like in all of these different source systems. And we need to add metadata. We need to clean up the data model. A lot of times, one example is when you profile it, you might see that 50% of the columns are empty. If they're empty, I don't need to see them on the diagram. I can delete them off the diagram. I can free up that space to use for things that are valuable. Then from there, and the business requirements that we've gathered from the top down and the understanding of what the business needs first. And we do this in a very iterative way because Rome wasn't built in a day and we can't boil the ocean. So we're going to pick some area and build it. And that's where we'll start. We'll mock up a star schema. So BI tools use star schemas or understand star schemas the best. So in the old days, we would try to define everything in Erwin. And nowadays, what's evolved is we just kind of mock up the star schema. Then we're going to use the either Coalesce or DBT or Matillion as our tool to build the star schema. And as we're building it, we're able to see the data so we can learn faster and build faster. Then we'll reverse engineer that into Erwin for QA and for communication and documentation. So let's jump to the next slide. One of my recent clients is a company called Aubuchon Hardware. They're a family-owned chain of hardware stores. They have 130 plus or minus. They are growing. They buy stores. They sometimes retire stores or sell them. And they are, we've been working with them for 2 years. We built their data warehouse. We built their BI program. And we had to learn their business. We had to understand the different source systems. They use a tool. They use a ERP called MI9. They have custom loaded it over the years into the various tables and fields. That, as an example, that's one of the systems that there's a whole bunch of generic column names that are not used. And so we did some top down to learn the business. We started loading the data, profiling, following that process. So I think this might be the last slide before we do the demo. Okay, here we go. Now what we want to talk about is how I want to demonstrate some of the methodology we use when we are using Erwin to build data platforms for our clients. So every time we go to a new place, people have different language. Each company will have slightly different terminology, and when you go from department to department, maybe the same thing is called something different. So we need to learn the business, and I need to represent that in a model. And so we talk about nouns and verbs, and I haven't even put the verbs on here. I guess it's just intuitive to me now. Anyway, so we need to understand the verbs and the relationships between the various entities. And so in this case, we needed some of the really important things were store and how stores. And if I hover there, we see the definition, which is going to jump off the screen. So I'm not going to hover on that anymore. But we have stores are assigned to teams. There are teams of stores. There are team managers that are employees that manage the team. And we have a corporate customer and a general customer, and we needed to learn the language. And so we use the top-down methodology to do that. So this one was kind of store, customer, and teams. Really quick, this one is for sales. And what was really important is that we learn where the data is coming from and how it's broken up so that we understand it a little better. And some examples. So as any retail outlet, right, they will have promotions, and the promotions might apply to a product or it might apply to a customer. The other issue the other nuance that we needed to be able to understand and demonstrate is that the way their systems are set up, the actual things that happen at the cash register. So a transaction line is every scan of the wand of a barcode. The transaction is the one sitting where people show up at the cash register, they get started on their transaction, they scan every item that goes into their cart or that they're going to be paying for. And so these are tracked as four separate distinct things. So they have a sale, which is the normal sale. They have fees if you're paying a fee for something. They have another transaction type, which is a return. And the fourth one is a special order. And those come to me from four separate files. And we needed to be able to represent that and then merge them back together. And I said four separate files, but I really meant from four separate tables upstream. So we also need to understand and represent that there are, when people pay for their transaction, they may pay for it in a variety of ways. And those are people who worked in retail probably already know all these names, but that's a tender is the money that you give to somebody, or, and it's not always money, it's the way that you pay for things. So it could be cash, it could be a credit card, it could be a coupon, it could be, those are the three big ones that I'll say. And then you may want to specify which, we would probably specify which type of credit card in the analysis. So that's top down. The next thing that's super important for us is we have to learn the bottom up. We have to learn the data and understand the relationships from the ERP that we're working with. In this case, it's an ERP called MI9. MI9 is an ERP for that typically I think focuses on retail. The one distinction that we had to make sure we understood is products versus product codes in this table name, but it's a product versus a variant. So a product is the model, or I think model is the right word for it. So this particular shirt is a particular model. It is from a particular manufacturer. It has a particular color scheme, but it is also it is tracked as variants. So each size will have its own variant ID, because they sell and they stock variants, right? There'll be, if you imagine a store with some shirts for sale, there's going to be a stack of shirts of different sizes and colors so that for a particular model, the various sizes and colors are stored as a variant. And what I wanted to show here is that the name of the table that stores the information about stores is called branches, and it has a not so intuitive. So it has this not so intuitive name for its primary key called levint, and that is a foreign key into this table, which might not be very intuitive, brand cats. But what we had to learn is that is the table that stores the ideal stock, the minimum, the maximum stock, and that's there right at the top. But a lot of attributes about how they want to stock a particular store. And so in order to be able to understand that, it helps me understand it, helps me communicate to other people once I have a diagram. So I think we've learned how everything works. We've learned the data well enough. We've started to design a star schema. Sometimes we'll sketch it out in Erwin. Sometimes we'll sketch it out on a piece of paper almost. But a star schema is going to have a fact table, and it's going to have a bunch of dimensions. I'm going to show that I'm going to show a completed star schema, or actually it's an in-progress star schema in a minute. But before I do that, I want to demonstrate reverse engineering in Erwin. So reverse engineering from Snowflake, I have to reach over here and grab the password. So now we have the password. And we are going to go to Actions, reverse engineer. I'm going to bring this up higher so it's easier to see. I use templates. So there's a whole bunch of things we can do and set them up in advance in a template. And I've been using templates for years. I have a particular style that I like. There's a few other things that I can show in a minute, but we're going to reverse engineer as a Snowflake database, which is mostly what I work with today. So we'll go next, and it should pop up. So now we're going to say next again. And now I need to do my connection. So I've already got my password, and I've set up my JDBC. This is our Cloud Data -prod Snowflake account. I'm going to look in the dev ODS DB database. Because that's what I set up for this demo. I'm going to use this particular warehouse, which is the compute cluster in Snowflake. And just to make sure I get everything and I don't have any permissions issues, I'm going to use the account admin role, which makes sure that I have permission to do anything that I want with this reverse engineering. So one of the things that's important is that we hit the connect button before we move forward. If we don't connect, when we move forward, we won't have any options to pick from, and we can't limit what we're going to be reverse engineering. So I'm going to hit connect. It's going to pop up a multi-factor authentication, which I need to click, and then we should now go ahead and connect. So now when I go to the next page, it will have populated the schemas for the database that I said I wanted to do for the reverse engineer in the demo. So I'm going to grab two schemas that I pre-populated just for this demo. And now I can pick from the tables. If I don't want to reverse it, in a production system, we may have thousands, if hundreds for sure, and sometimes thousands of tables. So for the demo, we just have a few. We're going to go next. We have one view, process report V. And if we go next again, we have materialized views, which I don't use materialized views. We use dynamic tables instead. They're a way better feature. Now, normally, much of the time, I would go through here and uncheck all of these. But what I want to demo, for the purpose of this demo, I want to show just how complete Erwin has been with the Snowflake connector. I can reverse engineer all of these things. I don't have all of them in the database, but I have a bunch of them in there. So we're going to reverse engineer everything. We're going to go next. We're going to go next. And one thing just to say about the scheduler, that is a really handy way if you want to schedule in the middle of the night when your production workload might be less, or maybe on a weekend when hopefully your production may be, depending on your industry, your workload might be less. But we used to, so on some production systems, we don't want to even add the load of reverse engineering to the system, so we will schedule it in off hours. That's never an issue with Snowflake, so we're not going to even worry about that. And I'm going to go ahead and click OK. So now we're going to have a couple of minutes, and it will go, and it's going to get everything object type by object type. It's pulling it in. Okay, here is everything that we've just reverse engineered. And what I can do here really quick, there are warehouses, there's the views, there are users. And what this shows is our naming standard for creating service account users. We have tables that we reverse engineered. Our stored procedures are there. The storage integration is there. The shares, and I could just keep going. But what's really powerful is that Erwin has set up so that I can reverse engineer all the different object types from Snowflake. One of the things that I usually do is set the shadows off. It's one of my things, but I need to update my template. The other thing that I need to do is go, because it says my template, I usually will come here, I will set properties, and then we can have a nice name, and we'll say the Erwin EM demo. And we'll close it. And now we have the name that we need. So because rather than make you watch me move these tables around, I'm going to flip really quick to the one that I did a couple of days ago and just put them in order. Otherwise, it was the exact same reverse engineering exercise. And what we want to talk about here is the different types of tables that Snowflake now supports. And we won't cover every single one, but the ones that we wanted to make sure we cover are the dynamic tables, which this isn't one of them, but the hybrid tables. So in Snowflake, a hybrid table is one that can handle OLTP-like workloads. So we can put a primary key on it, we can put indexes on it, we can treat it much like an OLTP table. Regular tables in Snowflake are designed to hold large amounts of data and to be optimized for OLAP, or online analytics processing. Online analytics processing versus online transaction processing. Hybrid tables can do online transaction processing, and then your data is right next to your analytics. Now, one thing that got announced this summer is Snowflake made an acquisition that's going to allow them to put Postgres inside of Snowflake. So coming soon, you'll be able to use Postgres and the features of Postgres along with your everything else you're doing inside of Snowflake. So what we want to show really quick here is another one that we made, and it was a dynamic table. And the cool thing about dynamic tables is that it's very similar to a view in that we say create dynamic object, right, table, hourly transaction summary, and we're casting the data types. We say target lag, which is the target of how often do I want that to be refreshed, which compute cluster do I want to use to keep it up to date. The refresh mode is incremental. We have several refresh modes we can use, but incremental is the best if we can get it. And what's going to happen is it's going to say this select statement will then be executed, and the data that's in this table will match this select statement. Now, the really cool thing is it's been physicalized or materialized, similar to a materialized view, in the actual table. But what's really powerful is when we tweak the upstream raw transaction table, Snowflake will detect those changes, and it will incrementally push the changes through from the raw table or the source table through into this table. Now, this is just a very simple example. We typically might have in a deployment 1,000 of these, and they are Snowflake will keep track of what changed upstream and then flow the changes through the DAG, the directed acyclic graph, which is a technical term for how we keep track of the dependencies in a system. And Snowflake will keep track of that, the directed acyclic graph, or DAG, and will push all those changes through for us, which is a huge boon for our operations. So we also have iceberg tables. Iceberg tables, what we want to say about that is for the demo, I created an iceberg table. I created a security integration so that it could, or a storage integration. And the gist of this is that when I inserted rows into this iceberg table, it goes through and it is stored in the in an S3 bucket that I set up as part of the demo. So having that allows us to copy data from anywhere that we have access to it in Snowflake, have it land in an iceberg table, which lands in the S3 bucket or The other buckets on the other S3 is Amazon's term for the backend storage. So we can copy data into the S3 bucket. It'll be managed. It'll have its catalog here. We can pick other catalogs besides Snowflake. There's several other catalogs, but that provides the ability to share data with other systems that are outside of Snowflake and use the best of all worlds to use the right tool for the job to access the data that you need. So we are looking at now, the one thing I didn't want to leave out is where we go to find the extra options we may need for depending on the table type. So if it's an iceberg table, there is an iceberg table options tab. If it is a dynamic table, we would have the dynamic table options tab, and we can take a look at it here, make changes, use the drop down. So since I didn't remember what the three types are, it's incremental, full refresh, and auto. And we prefer to have incremental. Sometimes we'll use auto so that Snowflake can decide how we're going to do the refresh. Full basically is the equivalent of a truncate and a reload on a dynamic table. So one thing I think I noticed is there's not a lot of options that we need to change for a hybrid table. It's either a hybrid table or it's not. And all we have to do is add the word hybrid in front of the DDL. So there's not extra stuff here that we need to talk about. There are, where else would we want to go? One thing I wanted to mention that I didn't create a demo for, but external tables are really powerful. One use case that we use for external tables is Amazon Web Services publishes weather data in an S3 bucket that's open to the world. And so we can point an external table at data in an S3 bucket and then be able to treat that data in an S3 bucket just like we would a table. We can select, we can basically select out of it. We don't insert, update, or delete somebody else's S3 bucket, but we can point to the external data and then treat it just like a table. And that's really powerful. Okay, we're getting close here to the end. One more thought that I was going to share really quick is, again, I'm just really impressed with how complete Erwin has handled all the Snowflake objects. Here we see the database roles, and what you're really seeing is the pattern that we use to build platforms on Snowflake. And one of the little pieces of the pattern is that every database has a name, either dev or prod, and every database has 3 roles associated with it. So there is an owner role, which is something that's a little bit different in Snowflake than most other databases. In Snowflake, it is a role that owns things. And so by using good naming standards, we like having the word owner and then finish it with role. And to use future-based grants, which is one of the coolest features in Snowflake, a future-based grant or future-based privilege is every time we create an object that is owned by the owner role, the grants get issued, select to the read-only role, and insert, update, and delete to the read-write role. And that saves us so much time and energy, you can't believe it. I never have to think about, or rarely have to think about grants anymore. So that was the grants. I think I talked a little bit about so there's our different databases with our naming standards, domains, which are really fun and powerful. One more thing that I really love about Snowflake is that we are able to set up security integrations and storage integrations. And they're a little bit related, but an example of a security integration is I can grant privileges from Google to Snowflake. And this one, Google SSO, lets me log in with Google. So I can use my Google IDP to log in to Snowflake. And this other one is an application we use called Syncery. And Syncery can connect to Snowflake with this integration. And then that means we don't have to manage credentials. So managing passwords or key pairs or credentials in general is kind of a pain. And in a related way, storage integrations, and this is one that I created just for the demo so that we could do the iceberg integration demo. So this gives privileges between Amazon and this Snowflake account so that I could then create this sales table, let me do this, get it back. So we could create this sales iceberg table, and the data now uses this integration to authenticate to the S3 bucket in my Amazon account. And now I can copy data into this iceberg table, and it automatically gets written to the S3 bucket. And I think that is enough on that. So we will just slowly, I think I might have mentioned warehouses and that we have different workloads. We have environments, dev or prod, and we have two different workloads. And for people who don't know, warehouse is kind of an unfortunate name, but a warehouse in Snowflake parlance is the compute cluster. And so warehouses can be t-shirt sizes, and each t-shirt size as it goes up gets twice as powerful, but twice as expensive. The really cool thing is that up to a point, if you double the size of the warehouse, you cut the time in half. And so your cost stays the same, but your runtime can be reduced drastically. So we have two workloads. We fine-tune them for business intelligence or ELT. And we can also have different developers or users in sandboxes that might need separate compute. Part of the reason to keep the compute separate is that if anybody messes up one of them, it doesn't impact the others. And it makes it easy to report on the billing. How much did we spend on each of these clusters or compute clusters? So there's that. Now, the very last thing we wanted to talk about is how do we QA what we have in production? So here is a star schema, which we have not, I intentionally did it at a state before it was finally done so I could show you the value of having a diagram when we want to QA. So that is obviously too small to read, but I'm going to bring this a little more up here. And what you can see there is we have naming standards, and one of the really powerful things that I found was class word abbreviations. And that was a standard that I learned when I was at Charles Schwab and their data warehouse team. And having a class word abbreviation at the end of every attribute or column name really helps with the cognitive load to understand what is in the column. The other thing that I prefer not to do is to not really have 16 megabyte columns. In my mind, a 16 megabyte column means that we didn't really think about the data type. In this case, there are some URLs. URLs have a maximum size. We should maybe allow a little bit more than the maximum size, or maybe even 2x, but 16 megabytes is too much. And then a really obvious mistake is when you see that it says that it's supposed to be a timestamp, but it's a varchar 16. And so here, this data warehouse synced timestamp being a varchar 16 is definitely wrong. And we can highlight these very quickly and give them back to our either the coalesce engineer, the DBT engineer, or the Matillion, or whichever engineer is making this happen. We can send this. We can identify these issues very quickly because it just jumps out at you, and we can send that back to increase the quality. And I think that's kind of the end of our demo today. Basically, we need data modeling for the modern data cloud, even as much or more than we did in the old days. I hate to use the term the old days, but I can't build a system without a data model. So modeling is really important. We need to document the business rules. We need to document the data. We need to design going forward, and we need to document what we finished building. So being able to use Erwin modeling with all the great Snowflake innovations allows us to deliver faster and with less risk, which is what I think of as safer delivery. We have less risk of cost overruns, of building the wrong thing and having to iterate more than we should. Anyway, faster deployments, fewer misunderstandings is the key.
And just for our audience, Bernie, I mean, thank you so much for showing things on Snowflake, but Erwin Data Modeler also plays very strong role in modeling Databricks or Azure, Synapse, BigQuery. So it really depends on it really doesn't depend on what kind of source you have. But my final takeaway with this webinar will be like metadata is very essential. It's critical to do any kind of data around kind of things you're trying to initiate or building. And data modeling evolves around your data. So, and it has to be a collaborative process. Your consumers, your producers, your data engineers, your data scientists, they all have to work in a collaborative environment. And the main key thing that, as I said, and I spent most of my time, was data mesh it is the key mind shift, paradigm shift that I'm seeing that is going to lead the market along with AI coming in the world. And AI is going to, of course, going to make our life much easier. So with this, I would like to go with my final slide here, which is what's coming in, what is there in version 15 that Bernie just demoed today. We released it, I believe, 2 weeks back or little around 2 weeks back. So you already saw DBT integration connector is there. So it is out of the box. So you just have to upgrade. If you don't see it, just upgrade to 15, you will see it. We also added orchestration integration with Jira. So very fully controlled. If you are using DM, you are using ER360, and you would like to keep your use cases where you want to control your orchestration of your support ticket. Let me explain in a business perspective. You have a data governance team comes in and says, hey, I need some changes in the model. So instead of doing things in an old-fashioned way via email, you go in Jira, create the ticket, data modeler gets notification in there, and they can make those changes, those final changes to your governance team, the people who really created, they can approve it. If they don't approve it, it comes back to the modeler again. So it's a very cool feature if you are using Jira. Open API, again, as I said in my earlier presentation, it's more about data scientists, your DevOps, your developers who are trying to build a framework around your application services. They can utilize the Open API system itself. It comes out of the box. We are constantly working DMDI to closer and closer. Business terms. So business term, if you think in this way, if you're a data intelligence user and you have business term defined in your glossary, you can make those business term being utilized by your DM. Now, a data architect, you don't have to do things through Mart now. The data architect gets the collection of those business terms and he can assign that this customer belongs to this business term, this identification belongs to this term of the glossary. Entra support we added. Bernie did a great job showing you the Snowflake dynamic table and iceberg. Thank you so much, Bernie, for that. And lots of enhancement and fixing things on ER360. So go ahead. If you're looking to get hold of version 15, go to support site and you can download it. What's coming next? I would like to keep my audience, our users, informed that we are very seriously working towards AI, and agentic AI is the next thing that is coming in. So September, October, we are coming up with the next release called 15.1, and that is our first step into getting into AI. So we are utilizing OpenAI, where when you reverse engineer or when you forward engineer, your DTL script can be analyzed by AI, assistance. So that's definitely there. You can validate it. It's gonna make you suggestions. That AI speed, it's basically going to add more productivity to your work. You don't have to do the manual validation. You don't have to come to support to for any issues. So this is something you might see. That is the our first step coming in September, where AI will be enabled. If you want, you can make it enable, and you can start utilizing it. From here, I want to keep some suspense. We are moving to agentic world. Agentic is going to take the entire tool in a different step. It's completely different, where agents are going to give you, it's more like agent driven data modeling. And that's something, if you guys would like to know more from us, please reach out to your sales rep, and we'll give you more in-depth demonstration on our plans. Something is agentic is going to come end of this year, and next year is all dedicated to our AI roadmaps. So a lot of interesting things beside AI, agentic AI. And if you are interested in, please feel free to reach out. With this, we would like to get into some FA question and answers. Bernie, let's see if our customers have any questions for us. So thank you so much for joining, everybody. And Bernie and I'll be more than happy to take your questions at this point. Thank you.